Welcome back to AI Homelab, your go-to channel for building powerful AI systems right at home. I'm your host Simon, and today we're diving into an epic showdown between the three leading language models: OpenAI's GPT-4 O1-Preview, Claude Sonnet 3.5, and Qwen 2.5 72b. Buckle up because we're about to push these models to their limits with some of the toughest questions in physics, logic, math, and coding. Now for this adventure, I've expanded my benchmark from 10 to 20 challenging questions to really test the capabilities of these models. We'll see how they shine, where they struggle, and what this means for you if you're looking to harness AI power at home, with your own server, or even with the API. Before we dive in, let me explain how the points are awarded. Each question is worth a maximum of 1 point. If a model answers correctly on the first attempt, it earns the full point. If it takes multiple attempts, the points decrease incrementally. A correct answer on the second try earns 0.5 points, the third attempt earns 0.4, the fourth 0.3, and the fifth 0.2 points. If the model only provides a partial solution, it earns half the points for that attempt. Even minimal effort is recognized at least a bit with 0.05 points if it gets something at all right. This scoring system rewards accuracy and efficiency, highlighting how well each model performs under pressure. Let's kick things off with physics, where we explore how well these models understand the fundamental laws that govern our universe. Physics isn't just about equations. It's about understanding how the world works, and these questions are designed to test that comprehension. Now I'll start with the first question. How could you melt a 30 centimeter ice block on a winter night using only one of the following items? A very powerful hydraulic press, or 0.2 liters of tea in a PET bottle, or a spoon. All of the three models nailed that one. They correctly pointed out that applying pressure with the hydraulic press would lower the melting point of the ice due to the pressure-induced phase change. It's a fascinating application of physics, and our models understood it perfectly, each earning 1 point. For the next question, imagine a bucket filled with water rotating on a rod with two holes, one pointing towards the axis and one away from it. How does the angular velocity of the water exiting the inner hole compare to the bucket? Again, all models got it right. They explained that the water from the inner hole would overtake the bucket because it's moving from a larger radius to a smaller one while conserving its momentum. It's counterintuitive, but spot on. Now we're progressing towards the third riddle. A hunter aims at a monkey hanging from a branch. The moment he fires, the monkey lets go and starts falling. Will the bullet hit the monkey? All models understood that both the bullet and the monkey are subject to gravity and will fall at the same rate, so the bullet will indeed hit the poor monkey. That's classic physics at play. Another point to each model. Now we are left with two more physics riddles. Here is another one. A Fiat 500 crashes head-on into another Fiat 500. Both cars have the same weight and collide without braking, each traveling at a speed of 80 kilometers per hour. Which of the following scenarios most closely matches the impact felt by the driver of Fiat A? Crashing into a concrete wall at 160 kilometers per hour, crashing into a concrete wall at 80 kilometers per hour, or crashing into a concrete wall at 40 kilometers an hour. All models understood the laws of physics and applied them correctly. They all selected crashing into a concrete wall at 80 kilometers per hour as the correct answer. This is because of the impact that is equivalent to hitting an immovable object at your own speed when colliding with an object of equal mass moving towards you at the same speed. So each model earns 1 point. Imagine driving with your sports car when suddenly you realize that there is a loop with 200-meter diameter. Which pace must you hold to get through it, and what forces will act upon you? All models calculated the minimum speed using centripetal force equations and got it right. Also, all models got the forces acting upon the driver right, so each model earned 1 point. Moving on to logic puzzles, let's see how the models fare when it comes to reasoning and deduction. Logic tests the ability to think critically and solve problems that require more than just factual knowledge. Now, on an island of truth tellers and liars, truth tellers are knights and liars are knaves. Kayla says, "My sister Timia and I are both knaves. What's their true status?" Now all models solve this riddle correctly. Since a knave would lie about being a knave, Kayla cannot be telling the truth if she were a knave. Therefore, Kayla is the knave and Timia is the knight. Full points all around. Next up is another knights and knaves riddle. This one is a classic fork-road puzzle. You arrive at a fork road where you find two guards. One always tells the truth while the other always lies. You don't know which one is which. You may ask only one of them a single yes or no question to find out which one of the both paths leads to safety, because one of them leads to death. What question must you ask to ensure to choose the correct path? Now, all models provided the classic solution. Would the other guard say that this path leads to the destination? This question cleverly accounts for both possibilities, ensuring you get the correct path regardless of whom you ask. Each model earns 1 point. We also posed a logic puzzle involving colored keys and numbered locks, a true test of deductive reasoning where the model needed to figure out which key opens which lock based on colors and numbers. GPT-4 O1-Preview and Qwen 2.5 72b had no problem solving this riddle, each earning 1 point. Claude Sonnet 3.5 didn't solve it, even after multiple attempts, so it's scoring 0 points. This puzzle required careful analysis of the clues, and it's impressive that the models could navigate through it. Although I'd argue that most 12-year-olds would probably also pass. Now close your eyes and reset yourself into the scene with the driver and the loop. We are going to see some more action. Now, far from being done with your action-packed day, you have to cross a bridge that can only support 80 kilograms. But you, your backpack, and your rope, they weigh more. You yourself weigh 75 kilograms, your backpack weighs 10 kilograms, and your rope weighs 5 kilograms. Now, how are you going to proceed? You need to get everything to the other side. GPT-4 O1-Preview solved it on the second try, earning 0.5 points, and it didn't kill the bridge crosser in the first try. It was just very vague and unprecise, so I wanted to push it towards a real solution. That was basically the same game with Qwen 2.5 72b, with the first try being really vague and a bit incomplete. And in the second one, it didn't kill the bridge crosser, but it was inefficient. And that's why I awarded it only half the points on the second try. Claude Sonnet 3.5 couldn't find a safe solution, and it would have killed the bridge crosser every single time. So it scored 0 points. Moving on from logic, now let's test their mathematical prowess with a deceptively simple question. Mathematics is the language of the universe, and even simple numbers can pose interesting challenges. And we are going to pose a simple question. Which number is bigger, 5.12 or 5.9? All models correctly identified that 5.9 is bigger than 5.12 in decimal notation. None fell into the trap of software versioning where 5.12 might be considered higher than 5.9. Full points again. Time to go into coding tasks, where we'll see how these models handle programming challenges. Coding requires not just knowledge of syntax, but also logical structuring and problem-solving skills. Now for the first question, I asked the models to create a Pong game in a single HTML file with specific features. GPT-4 O1-Preview nailed it on first try, scoring 1 point. Claude Sonnet 3.5 succeeded on the second attempt, earning 0.5 points. Now, Qwen 2.5 72b struggled quite a bit with this one. It was unable to produce a functional game even after multiple tries, scoring 0 points. Following this test, and for a true test of creativity and complex coding, I asked the model to create a single HTML file containing a homepage with 4 interconnected minigames, a selection menu, and an overreaching storyline titled Time Traveler's Challenge. The game should be playable directly in the browser, so all 4 of them, with options for playing against a computer or other players. This was a monumental task that required advanced planning and creativity. GPT-4 O1-Preview managed to partially solve it in 5 shots, earning 0.1 points. It laid out the basic structure and integrated some elements, but the games were barely functional and needed significant refinement. Claude Sonnet 3.5 and Qwen 2.5 72b both couldn't produce a viable solution even after multiple attempts, scoring 0 points. This challenge highlights the current limitations in AI models when it comes to complex multi-layered tasks that require extensive planning and integration. Now, as we already tested a game, we're going to test another game in HTML. The AI needed to create a Space Invader game entirely in one HTML file. GPT-4 O1-Preview did that flawlessly, scoring 1 point. Sonnet 3.5 took 4 attempts to perfect it, earning 0.3 points. Qwen 2.5 72b produced a game that worked but was insanely hard due to shooting pace issues. It never quite got it right, and the shooting was just so slow that it basically was impossible to finish the game. So it only earned 0.1 points here. Now, for the next tasks, we're entering the frontier of AI capabilities with some really, really tough tasks. These challenges require not just coding skills, but also advanced planning and creativity. Next up, the models needed to create a Python program that classifies numbers as natural, rational, or irrational using neural networks. Claude Sonnet 3.5 completed it in 2 shots, delivering a functional program and earning 0.5 points. GPT-4 O1-Preview managed to handle natural and rational numbers, but it struggled with irrationals, providing a partial solution and earning 0.25 points in 2 shots. Now, Qwen 2.5 72b got it right after 5 attempts, earning 0.2 points, while persistence pays off. For coding challenges, I like to combine games with machine learning knowledge. And this is what we did with the next task. The AI needed to develop an AI that can beat a human player 5 times in a row in an in-game. Now, GPT-4 O1-Preview delivered a flawless solution in 1 shot, earning another point. The same goes for Claude Sonnet 3.5, also earning 1 point. Qwen 2.5 72b got there after 5 tries, mainly struggling with their user interface, earning 0.2 points. Have you ever, as a child, tried to solve mazes on a paper with a pen? This is exactly what our models need to do, but they don't just need to solve them, they also need to create them, and they need to use neural networks and other machine learning algorithms. Now, this task involved complex algorithms and advanced neural networks. Unfortunately, none of the models fully succeeded in creating this program, but O1-Preview got close to it with a functional maze creator and an A-star algorithm that could solve the mazes. Only reinforcement learning didn't quite work, but it took 5 tries and the other models failed completely in this task. So O1-Preview got awarded 0.1 points for that, but the other ones left without any points. Next up, we had an even harder challenge. the models needed to develop a multimodal character recognition and generation system, basically a CNN. This highlights the current limitation in LLM capabilities at this level of complexity. None of the models solved that task. For the last ML and coding task, we're stepping into deeper waters. I tasked the models with developing a deep learning system capable of identifying the outlier word in a group of words. It could use embedding models, but the model must automatically download and manage all necessary resources, including pre-trained word embeddings, during a seamless user experience. GPT-4 O1-Preview managed to tackle this task, completing it in 2 shots and earning 0.5 points. It efficiently handled automatic resource management and developed a functional model. Claude Sonnet 3.5 and Qwen 2.5 72b struggled with this task and couldn't produce a working solution, both scoring 0 points. Heading on to the next segment, the models needed to create 3D games. They needed to develop 3D games in Python or in HTML. This is no small feat, especially within strict constraints. These tasks test the model's ability to handle complex graphical programming and its ability to basically think of space, which, yeah, they can't really do. For the first task, they needed to create an HTML 3D tank shooter. GPT-4 O1-Preview managed to create a functional, albeit imperfect, 3D environment because it had a lot of problems with perspective. It earned only 0.05 points because, yeah, it created something, but actually calling it functional is probably an overstep. It did something. Qwen 2.5 72b excelled in HTML 3D rendering, so the perspectives were really good, but it had some control issues and it also had problems with orientating itself, so the shots were generally fired towards the wrong direction and I couldn't get it to fire into the right direction, or when I pressed W, it would go backwards instead of frontwards, and I couldn't correct it even with angles. Claude Sonnet 3.5 struggled significantly with this task. It couldn't get anything done, so it scored 0 points. Qwen 2.5 72b, by the way, scored 0.05 points. So all the models, well, they did something, but it wasn't great. Now let's go to the next one. That one was HTML, now we're going to Python. The models needed to create a 3D racing game in Python. Basically just a car that drives. And if there were a track, I would be really happy. GPT-4 O1-Preview was the only model that managed to create a driving environment in 3D, and the car actually worked. So it earned another 0.05 points because there was no track and the car was a box. Yeah, so it wasn't great and it took it 5 shots, but the other models didn't get the 3D environment to work at all. So that one was the best. Finally, we'll sum up all the points of all the models. GPT-4 O1-Preview got 13.55 points out of 20. That's 67.75% right. Sonnet 3.5 got 10.3 out of 20 points. That's 51.5% right. Qwen 2.5 72b got 9.8 out of 20 points. That's 49% right. GPT-4 O1-Preview excels in complex problem solving and advanced coding tasks, providing comprehensive solutions, but it's also great at reasoning tasks and generally just at anything. It demonstrated a remarkable adaptability, depth, especially in advanced coding challenges and intricate physics problems. Claude Sonnet 3.5 was strong in logic puzzles, physics questions, and initially also in coding tasks, but it struggled with more complex programming challenges, and it's also sometimes struggling with logic challenges. Qwen 2.5 70b was outstanding in logic, physics, and math problems, making it a leader among open source models in these areas. It faces challenges with complex coding tasks requiring advanced planning and creativity. Now, for a final note, also, please run Qwen 2.5 72b in FP16 mode. It significantly enhances its performance, particularly in coding capabilities, making it a strong contender for tasks requiring detailed coding assistance. I'd argue it's pretty much close to the level of Claude Sonnet, perhaps not with the polish that Sonnet has. This enhanced benchmark with 20 tough questions truly pushed these models to their limits. It's fascinating to see how they handle different domains, from physics and logic to advanced coding and AI tasks. The varied performance across different types of challenges highlights the unique strengths and current limitations of each model. We're truly not at AGI or ASI, this is just hype. For those of you looking to build your own AI lab at home, insights like these are invaluable. Depending on your specific needs, whether it's coding, assistance, problem solving, or logical reasoning, you can choose the model that best suits your projects. For coding, I'd probably still go with DeepSeek 236b if you can run it. Remember, AI is rapidly evolving. There are better models coming each month. The challenges that models struggle with today might become their strengths tomorrow. That's the exciting part. We're all part of this AI revolution, and I can't wait to see where it takes us next. There's so many cool projects that are delivered each day. Now, thanks for joining me in this deep dive into AI capabilities. If you found this video helpful, please give it a thumbs up and subscribe for more insights into building your own AI systems at home and benchmarking new AI models. Let's continue to explore, experiment, and push the boundaries of what's possible together. If you have any questions or suggestions, please write it down into the comments section. Until next time, see you.
Turning wires into dreams, building blocks of air and cold from beneath the surface scenes where imagination flows, chasing benchmarks, crafting AI pieces, so tuning out the rhythms, always reaching forward. AI Homelab, light up the screen, every revelation and every guess a dream, innovate, create from the ground up, high in the heart of machines under the open sky. In the lab with circuits on my artistic F5, every breakthrough made bring the future to life. Pushing boundaries, vision, coolings, typing, pride, passion needs precision in this digital time. AI Homelab, ignite the core, limitless potential, pushing ever more, educate, debate with every probe we try in a symphony of progress, reaching for the sky. In the lava dreams where vision not there, explain, breaking through the norm in a groundbreaking way. From keeping us seasonally data and sound with passion, resolve to new heights for bound. Every lick of neon, tested in the AI Homelab, where perfection instance with the future that I've been through, both calling lore, reminiscences of my best, ready to go explore. AI Homelab, light up the screen.